Okay, tonight, I want you to do something. If you can, get away from the city lights and just look up. You'll see it. That faint, glowing band stretching all the way across the sky. That's our home. That's the Milky Way galaxy. And in this explainer, we're going to take a grand tour of our cosmic neighborhood. You know, for as long as we've been, well, we've been staring up at that same sight. It's kind of amazing to think about. Even the poet Chaucer, way back in the 1300s, was writing about the Milky Way, for the simple reason that, quote, it is white. That very sight connects us, right now, to our most distant ancestors. It's a shared heritage written in the stars. So what are we actually looking at? I mean, really, is it a river of light? Milk spilled by a goddess, like some of the old stories say? Or is it something so much bigger, so much more incredible? Well, that's exactly what we're going to dive into. We're going to peel back all those layers of myth to get to the absolutely stunning science of our home galaxy.
All right, so first up, a river of stars. Let's start by looking at how our whole view of this thing has changed, from ancient poetry to modern physics.
I mean, look at these names from cultures all over the world. The Silver River, the Bird's Path, just beautiful, right? But then came 1610 and Galileo. He points his brand new telescope at that river and whoa, it wasn't a cloud at all, it was stars, just countless individual stars. That one observation was a total game changer. What we know now is that we're looking at a massive barred spiral galaxy from the inside. We're sitting inside this giant spinning city of hundreds of billions of stars looking out through one of its long, winding arms.
Okay, so our place in the galaxy. If we live inside this thing, where are we? To even start to answer that, we have to get our heads around some scales that are, frankly, just mind-boggling.
Okay, let's try an analogy to wrap our heads around this. I want you to picture our entire solar system, everything out to the edge of Neptune's orbit, and shrink it down to the size of a quarter. Got it? A little quarter in your hand. Now, on that same exact scale, the Milky Way galaxy would be the size of the entire continental United States, the whole thing, from New York to LA. That's the unbelievable emptiness and sheer size of our home.
And we're not exactly downtown in this cosmic USA either. Nope, we're way out in the suburbs, about 27,000 light-years from the super busy galactic center. Think about that, 27,000 light-years. That means the light from the core that you could theoretically see tonight left 27,000 years ago. And get this, we're not just sitting here. We are screaming through space, orbiting the center of the galaxy at something like 220 kilometers per second. I mean, just unbelievably fast. But even at that insane speed, one single lap, what astronomers call a galactic year, takes about 240 million years. The last time our planet was right here, in this spot, the very first dinosaurs were just starting to show up. That's wild. So, how crowded is this cosmic city of ours? Well, the estimates go as high as 400 billion stars. Let that sink in. 400 billion suns. And almost every single one of them is likely a potential host for its own family of planets. Okay, but this next number, this is where it gets really interesting. Thanks to missions like the Kepler Space Telescope, we now think there could be, wait for it, up to 40 billion planets about the size of Earth, orbiting in what's called the habitable zone. That's the sweet spot, not too hot, not too cold, where liquid water could exist on the surface. 40 billion potential water worlds, just in our galaxy alone. The implications are staggering.
So let's put this all together. It's like our cosmic address. Ready? We're on Earth, which is in the solar system. The solar system is tucked away in a little spur called the Orion Arm. That arm is part of the big Milky Way galaxy. The Milky Way is one of the main players in our little galactic neighborhood, the local group. The local group is on the outskirts of the Virgo supercluster, which is just one tiny branch of the absolutely enormous Laniakea supercluster. Really makes you feel small, doesn't it?
All right, now that we know where we are, let's zoom back in. Let's take a look at the anatomy of the Milky Way. What are its actual parts? So, what shape is it? For the longest time, we thought it was just a classic, simple spiral. But it turns out that's not quite right. Newer observations, especially in infrared light, confirm that we actually live in a barred spiral galaxy. And that bar makes a huge difference. It's this big, dense, bar-shaped structure of stars right through the middle. You can think of it like a giant cosmic pipeline, funneling gas and dust toward the center to spark the birth of new stars. So let's take a quick tour from the inside out. Right at the dead center, you've got a supermassive black hole. They call it Sagittarius A star, with a mass of 4 million suns. Insane. Coming out from that is the central bar, which is mostly packed with older stars. Then you've got the famous spiral arms, which are like the galaxy's nurseries, full of gas and dust and brand new baby stars. We live in a little neighborhood called the Orion Spur, which is nestled between two of the major arms. And then, wrapping around the whole thing is this huge ghostly sphere called the halo, where you find the most ancient stars in the galaxy.
But here's the part that will absolutely blow your mind. Everything we just talked about, the black hole, the bar, all 400 billion stars, all the gas, all the dust, all of it only makes up about 10% of the galaxy's total mass. So, where's the other 90%? Well, it's something we call dark matter, and we have no idea what it is.
You might be asking, well, if we can't see it, how do we know it's there? And that's a great question. It all comes down to how fast things are moving. See, in our solar system, the outer planets like Neptune move way slower than the inner ones like Mercury. That's just basic gravity. So we'd expect stars on the edge of the galaxy to move much slower than stars near the center. But they don't. They're all moving at roughly the same, really high speed, and that just shouldn't be happening. Unless there's a ton of extra, invisible mass providing the gravitational glue to hold the whole spinning thing together. That's dark matter.
So, onto our galaxy's violent history. And it's important to remember, this super detailed picture we have now is really new. For most of human history, we were basically clueless. So let's take a look at how we figured all this out, because it reveals a story that's way more chaotic than you might think.
Our understanding really happened in a few giant leaps. First, you've got Galileo in 1610 proving the milk was actually stars. Huge. Then, William Herschel tries to draw the first map, but he gets it wrong. He thinks we're at the center because dust was blocking his view. But the really big paradigm shift came in the 1920s with Edwin Hubble. He proved that all those little spiral nebulae in the sky were actually other galaxies, millions of light years away. Suddenly, the universe got a whole lot bigger. And now, today, we have the Gaia Space Telescope, which is mapping over 1 billion stars in 3D. With such incredible precision, it's changing everything all over again.
And with the tools we have now, we can basically do galactic archaeology. It's so cool. Stars are like fossils, right? The really old ones are alpha-rich, which means they're made of the simple, primitive stuff from the early universe. But younger stars, like our sun, are alpha-poor, but they're full of heavier elements, iron, carbon, you name it, that were cooked up inside previous generations of stars and then blasted out into space. So by looking at a star's chemical fingerprint, we can literally read the history of the galaxy. And it turns out that family tree is pretty violent. The Milky Way didn't just pop into existence. It grew by eating other galaxies. It's a cosmic cannibal. We can actually see the leftovers, the shredded remains of these galactic meals in the stellar halo. And one of the biggest meals was a galaxy astronomers have nicknamed Kraken, which our galaxy devoured about 11 billion years ago. Just amazing.
Okay, from the violent past to the equally dramatic future. What's next for the Milky Way? What does the future hold?
Well, it turns out the next big merger is already scheduled. Our biggest neighbor, the Andromeda galaxy, is hurtling straight for us at over 100 kilometers a second. In about 4.3 billion years, the collision begins. Then, over the next couple billion years, gravity will do its thing. The two spirals will get shredded and then reformed into one single, gigantic new galaxy. Some people have already nicknamed it Milkomeda. But here is the final, absolutely mind-bending twist. Even though we're talking about a collision between two galaxies with 1 trillion stars between them, the odds of our sun actually hitting another star are almost zero. It's just not going to happen. Why? Because the space between the stars is just that vast. It's more like 2 clouds of smoke mixing together than a car crash. The night sky will look completely different for sure, but our little solar system will probably just get flung into a new orbit in that brand new galaxy. So there you have it. We've gone from ancient myths about a river of milk all the way to a future cosmic collision. We've mapped out our address, we've dissected the galaxy's anatomy, and we've uncovered its violent, cannibalistic past. And yet, the biggest piece of the puzzle, that 90% of our galaxy that's made of dark matter, is still a complete blank spot. It's a pretty humbling reminder, isn't it? As much as we know about our cosmic home, we've probably only just begun to understand it. Makes you wonder, what other secrets are still hiding out there in the dark?